Solar energy is incredibly abundant, but it is also difficult to harness with good efficiency. We would all use the sun's free energy to power cities and light our homes if we could. Looking over a smoggy city, you want some ray of hope for progress. Many solutions are available, but how do we choose with so many options? And what options do we have at night, or when the sun is hidden? In fact, peak energy use does not match peak solar availability. For the most part, we tend not to need the energy when the sun is at its peak. We often need it later, or earlier. We could use lots of batteries to store the excess energy from the day, but this would be too expensive. Batteries are quite useful, but not when scaled in size or quantity with an energy capacity to replace solar. Not to mention they can be toxic and have a short lifespan for such continual and demanding use. The batteries must also be recycled, and maintenance will be a large drawback from continuous reliable energy generation. So what we need is solar electricity generation from efficient PVs, a way to control how the power is used to account for time discordance and peak use versus peak availability, a reliable high-capacity energy storage system to store excess energy and keep up with the power use throughout the day, and a workable design that stands out in the smorgasbord of other green energy designs.
Reaching our technical overview, our system consists of a concentrator, triple junction photovoltaic, reversible fuel cell with a carbon fiber hydrogen storage tank. A light-guided solar optic concentrator, LSO, tunnels incoming light rays into a triple junction PV. A controller will be implemented to help regulate the energy needs between the PV system and a reversible fuel cell. Concentrated photovoltaics, CPV technology, uses optics such as lenses to concentrate a large amount of sunlight onto a small area solar photovoltaic cell. Our hybrid system optimizes solar concentration by using a thin acrylic optic that traps light and guides it towards its center. To better improve the incoming light collection efficiencies of all incoming light rays, our PV concentrator will be implementing horizontally staggered light guide technology. The top layer of our proposed triple junction solar cell consists of aluminum gallium indium phosphide. This layer sits on a middle layer of aluminum gallium arsenide. Both of these layers reside on a germanium substrate. Basing the PV off of a germanium substrate and following two design parameters, lattice matching and current matching, a triple junction solar cell was designed. To match currents, the photon flux from the sun was divided into 3 equal parts. The energy levels defined by this condition, combined with matching germanium's lattice constant, led to a PV design with a theoretical efficiency of 53%.
As for the fuel cell, we utilize the reversible TMI solid oxide fuel cell. It has 2 modes. One is fuel cell mode, which generates the electricity of 75 to 95% efficiency. The second mode is electrolysis mode, which generates the hydrogen, have 85% efficiency. The operate temperature is from 800 to 1000 Celsius. And we apply a very cheap global-based catalyst. The reason why we use this fuel cell because it's high efficiency and low cost. Our hydrogen storage equipment is hydrogen gas compression, which made by a carbon-based materials with a 1/2 thickness of steel. It costs $28 per kilogram.
The system just described drives our entry into the photovoltaics market, which was valued at roughly $31 billion in 2010. About 1/3 of this is comprised of medium-scale installations, our target customers. This market is highly competitive, with no single company controlling more than 10%. Over the past few years, the market has seen rapid expansion, with a 66% compound annual growth rate. Our target market is estimated to be $26 billion today. We believe that there are a large number of customers who have been hesitant to adopt solar energy because of its intermittent nature and the high cost of battery systems. With our low-cost, scalable energy storage system, we can expect to see expanded utilization of solar electricity, reducing dependence on fossil fuels while producing clean, sustainable energy.